Good afternoon, everyone. My name is Lucy Roche, and we are joined today by Emma Woods, one of our principal consultants, who is also from Turner & Townsend. So the purpose of this event is a retrofit information support and expertise event. So it's a RISE event, which is fully funded by the Department of Energy Security and Net Zero, delivered through Turner & Townsend. Thank you again for everyone for joining. I'll now hand over to Emma to start today's presentation.
Thank you, Lucy. So today we're going to be talking about managing technical risk when it comes to retrofit. So we'll start off by talking about where does retrofit usually go wrong, how we can actually start identifying some of those risks, mitigations, and then risk management when it comes to past 2035. And if you aren't aware of what past 2035 is, I'll give you a brief overview as well. So where does retrofit go wrong? So we've got a few different examples here on screen. So the first example there is a case study in Fishwick in Preston, where 300 homes were rendered as kind of damp and uninhabitable due to poor quality design and installation of the external wall insulation. So the external wall insulation was poorly fitted around where the guttering and the windows were, which meant that a lot of the moisture was saturating through into the installation, which eventually caused a lot of damage to the interior surfaces, and that resulted in things like black mold and fungal growth. You also have the second case study there in the middle. So this was a case study in Swansea where they had defective cavity wall insulation, which again caused damp and mold in thousands of properties. So what happened was there was water ingress into the actual cavities itself, and it was not spotted during the initial survey or installation, and again, which meant it infected or affected the interior aspect, causing damp and mold. And the last one is another North Wales example where 104 homes were rendered damp and uninhabitable due to inappropriate use of EWI. So very similar to the first one, there was water ingress between the existing wall and the external wall insulation due to poor insulation. So where there were kind of the fittings were done, it allowed moisture to kind of seep in for where the guttering in the windows were, which again kind of caused damp and mold problems. So there's quite a common theme when it comes to kind of retrofit going wrong. A lot of it's down to kind of poor installation to start with, not thinking about the technical risks of where the moisture will go. And also there are other examples as well that don't just consist of external wall insulation, but we'll talk about those in a second. Here we go. So what has this kind of taught us? So you can see when it comes to retrofit going wrong, they're usually split into three different categories. So the first is the interaction risks, and this is where one measure meets another, so it can occur during the junctions and the edges. So for example, where the floor meets the wall or the wall meets the roof, etc. So where you've got interaction risks is usually where you've got joining components. So what happens here, this creates kind of risks such as like water penetration, thermal bridging, thermal bypasses. So where you've got a window and attached to a wall, there's usually, if it's not being installed correctly, it can result in kind of thermal bridging, which means air can kind of penetrate through those different areas, or heat can penetrate through those different areas, causing kind of moisture to build up. So if you're not familiar with what thermal bridging is also known as a cold bridge, and these are weak spots or areas in a building envelope which allow heat to pass through more easily. So they occur when the materials are better conductors of heat, which allow to form a bridge between the inner and outer phase of construction. So this commonly happens where there is a gap in insulation layer, or where there's an element such as a joist that penetrates through the construction. You can also have things like thermal bypass, and thermal bypass refers to air movement through or around the insulation, so effectively bypassing its purpose and reducing the thermal performance. A good example of this could be a unventilated cavity wall, such as a open loop convection, which allows air mass to be replaced by other air, and therefore includes kind of air gaps between the permit airflow, and thus kind of heat transfer between two different regions. So you've got your interaction risks, And then the next risk is interfaces. So this happens where between the fabrics and surfaces, you've got issues with tightness and ventilation. So for example, you may go to insulate all the floorboards, but not have any ventilation underneath the floorboards for air to circulate, which can result in kind of damp and mold problems. And then there are other interfaces like the insulation and heating itself. So making sure there's enough enough insulation to allow for adequate heating. And then the last is in actual between the services and the people. So poor handover and incorrect use of a property. So for example, people not correctly ventilating their properties, so hanging their washing inside, but not allowing for any ventilation. That can also result in kind of risks, but also things like poor maintenance as well. So if you're not sure about kind of the maintaining the guttering systems, and the drainage systems, it might mean that that will end up building up, and then moisture ingress can happen between the external wall insulation or the cavity wall insulation. So the other element is around moisture risk. So we talked a little bit about this before, but you've got kind of moisture risks that overlap with kind of the previous risks discussed in the previous slide. So most retrofit risks are related to moisture, and what we do is talk about the water penetration. So that's where kind of water penetrates into the property. And then you have condensation. So if there's any kind of, again, if you kind of start cooking, for example, and you're building up all the moisture and heat from the cooking, you'll get condensation problems. And then you also have deterioration. So penetration dampness could be caused by kind of roof or guttering or roof, gutter, or leak pipes. Problems of this sort can be quite straightforward to fix once they've been identified, although the dampness may kind of take time for it to dry out. So in this case, using kind of dehumidifiers to help speed up that drying process. You can also get risk of rising damp. So this mainly affects ground floor rooms, and this is caused by the groundwater soaking up into the walls, and is usually because the damp-proof coursings at the bottom of the house or damp-proof membrane is not working properly. So there's no damp proofing. So sorting rising damp can require quite extensive work, especially if the damp has leaked into the wall, plasters, meaning you have to completely rip off all the plasters on the wall and then replaster it. Obviously drying the wall out first and then kind of replastering it. With condensation, so this is a problem associated with moisture created actually inside the building. So as we mentioned, for example, cooking or again, hanging your laundry inside. So the moisture buildup inside the building kind of can create the presence of things like black mold, and that's usually where you've got condensation problems. And again, this can be caused if there's not adequate insulation, ventilation, or heating. So it doesn't just have to be about ventilation. There's lots you can do to minimize condensation and to prevent black mold growth. A lot of it has to do with users, like the users inside the properties, making sure they're correctly ventilating and heating their property, but also making sure that the insulation is adequate. And then you've got things like collateral damage. So where your adjoining properties might have similar kind of problems, where they've got damp problems next to it, which may seep into your walls next door to you. And then you've also got where properties are not being correctly insulated next to you, causing kind of cold external walls and frost damage. So where does retrofit go wrong? So I'm just going to grab a little pointer. This is the process where we start. So you first understand what the process risks are. So first, what the customer care is, specifying what appropriate measures are needed, and then ensuring the integration of measures and the sequencing of the measure installations itself. So we start with understanding what the triage matrix is in terms of the risks required. So whether it's low risk or high risk. So if the measures that are required tend to be higher risks, then you'll end up needing a more detailed assessment of the property. Then when you think about what detailed assessments required, you have to figure out whether or not that is something that you can do internally or has to be subcontracted externally. If it can be carried out internally, then you can go through to your fact sheets to work out what those or identify those different risk assessments. And then there are different ways to do this. So you've got fact sheets, you've got watch points, and then there's something called the STBA guidance wheel. So all of these things are related to the different risks associated to the measures you're looking to install into the properties. And then the one next to it, if no, you haven't got those risks in-house, what you might want to carry out with the external kind of contractors, subcontractors, are risk workshops, detailed audits of the property, getting a retrofit coordinator on board and looking at what monitoring and evaluation can be done pre and post works. If when you're starting out actually through the triage matrix, the measures that you're looking to install into the property are relatively low risk, then you can use existing online tools to help carry out some of those risk identifications yourself. So watch points, fact sheets, or STBA guidance wheel. So we'll talk a little bit about some of these tools towards the end as well. So diving into one of the case studies, I sometimes feel bad bringing up this case study all the time, because I will say, having done or having kind of spoken about what's gone wrong with this property, there are actually a lot of positives that have come out of it, and they have since rectified it and carried out all the kind of mediation works for it. So I will kind of caveat that although this is case study kind of comes up quite a lot, they have rectified all of these mistakes since. So as I mentioned, this case study is based in Fishwick in Preston. So the properties undertook some energy saving works through the Community Energy Saving Programme scheme in 2013. And it cost a total of around £5 million to retrofit these 300 properties. And the issues included defective insulation, so no design, no ventilation strategy, and it led to widespread damp and mold. So I'm just going to point out the example here. So where you can see where the external wall insulation has been installed, you can see there's a thermal bridge there between the roof and also the drainage being kind of on top there. The water can then leak on top, and then water ingress can happen through that external wall insulation. Similarly, here to the right, you can also see that there is a thermal bridge where the walls have not been joint in properly, or has not been installed in properly, again resulting into a thermal bridge, and also risking where moisture or water ingress could happen. So the result of this has meant a lot of the damp and mold problems happening inside the property, which they had to then kind of rectify by removing the parts of the external wall insulation and extending the roof verge to make sure it didn't have any water ingress, and reducing those thermal bridges. So efforts have been made, as I said, to correct these issues. So currently cost for remediation to date is estimated at £6 million, which, having already spent the £5 million initially to carry out the retrofit works, obviously this is a significant cost to remediate those works. The cost of unintended consequences and the impact on the residents' lives could eclipse this kind of estimate. So hopefully what we're trying to find out today is how we can mitigate some of those risks from happening in the future. So risk identification. So firstly, how do we identify the risks associated with retrofit? So a whole series of work that we can look at. So the first one is Retrofit for Future, and this is a £17 million Innovate UK programme, and this involves deep retrofit of 115 houses in 86 projects. So 2 years of monitoring, evaluation and reviews have identified what went on to carry out some of those retrofits. So great strength is learning what went wrong as well as what a success was. So this was a programme that happened as part of the Innovate UK programme that happened in Leeds City Council. There's also a programme for eco programme failures. So this is where all the failures kind of discussed there on the right. So again, Preston 2013, so that one we just talked about. In Wales 2013, where damp and mould in several villages were caused by badly insulated EWI. So I think that was one of the first ones we pointed out in the first slides. And then Edinburgh 2014, where the outer leaf fell off the insulated gable of a school wall. Also missed out Glasgow there. So Glasgow, 4 tons of EWI fell off the top of a story of a residential tower. And then the last, so Grenfell as well. So in 2017, 72 fatalities over a fire spread via new external cladding. So cladding that wasn't fit for fire safety regulations. And then the numerous individual installation failures between 2010 and 2012 2020. And these were mostly kind of inappropriate installation of EWI and CWI. So Eco4 program failures have also helped us in being able to identify where some of those risks have gone wrong in the past. The GLA Renew program, so there are many learnings from this program. This was a government support program for London, which referred, and this kind of diagram on the right kind of refers to a risk matrix. So this was developed by Lisa Pasquale, who, if you've been involved in kind of our previous masterclasses, she's run a few of our past 2035 and monitoring and evaluation masterclasses. And what this matrix aims to do is to deal with evaluating the inherent technical risks and how improvement measures interact with each other and how this may cause issues. So what you can see here, for example, is IWI. IWI, what the risk factor is, so 3 being relatively high and 0 being not very risky. So, for example, certain measures like mechanical ventilation, heat recovery systems, and IWI, their interaction is really important. Whereas if we take something like solar thermal and cavity wall insulation, the kind of technical impact or the interaction impact is 0. It's not as high. Also, where things are highlighted in green, there are kind of where you may also take additional assessments in place to understand what the inherent risk is. There's also the Centre of Refurbishment Excellence. So this was a project based in Stoke-on-Trent, which was funded by the EU. And this did a lot of work on the process of retrofit itself. So what is the process to retrofit? What do you need to carry out in order to identify some of those risks? So it kind of conceived the idea of retrofit coordinator, looking after the whole project process and taking responsibility from an end-to-end point of view, so right from the start to the beginning. So what this defined was the assessment process, the design process, the installation process, and the operations. So within all of this, the assessor specialization and deployment took place, so that being the retrofit coordinator. During the design, understanding what materials, products, details, and procedures were required, and then carrying out the actual risk assessment itself before carrying out any installation. And then once the installation and operation, or once the installation has happened and once it goes through operations, then taking a sample inspection and monitoring the performance of the homes. So having that rapid feedback, and if there were anything wrong, then again carrying out some of those risk assessments to identify what improvements needed to take place. So this one is the STPA UK guidance wheel. So this is something that I actually use quite a lot with my clients on a day-to-day basis. And this helps kind of, again, identify what the interaction is. So similar to the one with the Renew program where you had a different matrix, this one kind of shows the interaction at a different level. So for example, where you've said, for example, this might be external wall insulation, it can say what the interaction with external wall insulation is with the roof, floor, windows, and the different types of windows as well. So it breaks it down by the different kind of types of windows. So this was set up with funding in order to understand what the issues with retrofit on buildings and technically which are kind of technically difficult to improve and potentially vulnerable as part of the architectural heritage as well. So again, if you're carrying out some external wall insulation, then what kind of impacts does it have on the heritage properties? Then the last one is the UK Centre for Moisture in Buildings. So this is a UCL case study. So a lot of detailed scientific research was carried out to determine how moisture moves through a building, both with retrofit and with new builds. So this basically helps to look at how we can better assess, monitor the moisture levels within buildings to better produce the outputs that we need to. So that's how we got started with risk identification for some of the retrofit projects that have been undertaken. So we're now going to start looking at risk mitigation. So starting off with that risk assessment process that we talked about, you've got the assessment stage, the design stage, installation, and the operation. So during the assessment stage, these are some of the risks that you might that might kind of come up. So starting up with not having the right assessor in place and not having that retrofit coordinator or someone to be able to help carry out those assessments in place can lead to incorrect measures being suggested, or not have it, or making sure that it's not relevant to that specific building and not making it specific enough to that home. So one of the mitigations is to carry out triage assessments. So not just relying on a single person within your team to carry out a risk assessment for all your properties, but actually to get some external support and carry out a triage assessment of the different risks for the properties. Then you've got inaccurate assessments. So if you've got an inaccurate assessment, then you're bound to get a inaccurate improvement measure and get the wrong output for the building. So the best mitigation for this is making sure that you've kind of procured the right type of assessment to carry out and making sure it's been certified, or the person carrying out those assessments have been really well trained. And then you've also got wrong measures being recommended. So if you have any wrong measures being recommended, going back to kind of making sure doing your triage assessments. And then other things that could go wrong: optimistic fuel cost savings. So when you're recommending measures to your residents or to a specific property, then not being overambitious in what those fuel cost savings are going to be, because you might take into account fuel price fluctuations. So it might not necessarily be as what you initially modeled. And that's why carrying out things like occupancy assessments at the end to actually find out how the residents are finding the home is more important. Then we'll look at some of the design risks. So here are some of the design risks. You've got poor retrofit strategy. So if you've got a poor retrofit strategy, you're not always going to take a fabric first approach, which means inappropriate kind of different services. So for example, installing a air source heat pump onto a property that isn't well insulated could result in further risks down the line for the resident. Poor integration of measures. So this is where you've got discontinuous insulation or discontinuous air barriers, or kind of poor matching of different services with different fabrics. Overheating. So this is where you can carry out retrofit, but you've got inadequate shading or ventilation in place, really resulting in overheating risks. And then the next one is poor communication. So this is where occupants are not engaged and the design intent and dependencies are not clear, which could lead again to poor retrofit interventions. So if we look at some of the mitigations for design risks, then we've got first, carrying out fabric first approach. So making sure the fabrics, the services, renewables, energies that you're considering are kind of fit for purpose, and you've accounted for the phasing of the works as well, so that they reduce any technical risks. The next is around mitigations for servicing, so making sure you've got a good ventilation strategy in place, so matched to what your fabric air permeability is going to be for those specific properties, considering what supply, extract and heat recovery systems might need to be in place, but also efficient and responsive heatings as well, and making sure that the control elements for those different heating systems are also user-friendly. Other design mitigation then is communicating early, so to your occupants and installers, making it really clear what the lines of communication responsibilities are for the different elements of the retrofit, and also the specification and construction details, by having that all to hand and ready to your contractors. So now we're going to look at some of those risks from installation. So first, it's popped all up. So the first one is poor integration. So multiple installers at different times, and there's no overall kind of coordination or overall responsibility. So that's where poor integration can happen. The other risk is around inappropriate substitution. So inappropriate kind of substitution for different materials and products, and not suggesting the right kind of substitutions. And then you've got poor installer design. So location of different services and controls, not knowing where they're happening. And then also ventilation ductwork as well. So again, if you haven't got the right installer design for what the ventilation ductwork should include alongside some of those fabrics. And then lastly is poor commissioning. So systems kind of not being set up and tested as and when you'd expect it to. And then if we look at some of the mitigations of some of those risks for retrofit works during installation, you've got multi-skilled teams. So making sure that the trades that you've got onboarded are integrated into the teams, but also the team are constantly being briefed by the designer and the specifier, so that they know what works are going to be carried out. Change management control, making sure there's kind of mandatory reference to the specifier of what those change management control processes include. And then detailed design of surfaces. So this is making sure that the installer design is kind of forbidden and you haven't thought about what the installer design is, and it's more just by what the designer and specifier has in place. And then lastly is commissioning. So all services happening together, not separately, and making sure that there's a formal handover to the occupant. So now we're going to look at the risks when it comes to operations. So the first one is around condensation and mold. And this, again, the risk is when there are different surface and institutional intersexual mold and damp consequences. And then you've got also things like danger to the occupant's health and danger of long-term deterioration. Then you have controls not used correctly, so occupants don't know how to correctly use those different systems or heating systems, for example, the controls for an air source heat pump. There are too many different controls or it's too complicated for them to use. Then you have risks for systems being disabled or overwritten. So, for example, occupants might dislike the noise or the different drafts coming through the room, so they block up certain ventilations, which again could lead to risks of further damper mold problems. Then you have the last one, which is the poor energy performance. So the risk of being, when you've carried out all the assessment, the predicted savings are not realized, or you've not really thought about things like summer overheating risks. So thinking about those things beforehand can help you understand what those potential savings or mitigating those overheating risks to start with. So in terms of mitigation, then you've got verbal and graphic handover processes, making sure that those things are different, they're kind of explained, and the different control systems are explained to the residents, and then consequences of the disabling these different systems as well. So if you have the right handover procedure in place, it's less likely to have any issues with disabling those different systems or blocking up those vents. Then you've got sample post retrofit testing, so actually carrying out a tightness test or pressure tests, but also things like thermal bridging, so checking once you've installed the properties to see if there's still any risk of kind of thermal bridging between the windows or any kind of joining of different components. Promoting appropriate behavior, so making sure that you're pulling together the right energy advice notes, how to mitigate some of those overheating risks, so making sure the right kind of shading is in place, and then lifestyle changes to kind of suit the retrofits that have been undertaken. So now we're going to talk about risk management when it comes to past 2035. So this paper on the right, it introduces the 4 C's, so context, coherence, capacity, and caution. So context, this is where we're talking about what is the geographical context in this, what's the legal and cultural context in the risk that you're talking about. So this is consistency, approach to moisture, ventilation, internal air quality issues. Capacity. So capacity issues in particular, we have a tendency in kind of the building industry to minimize everything and design and specify everything to the minimum capacity, rather than actually just to kind of meet the building regulations, which are already kind of minimum standards. So what we're talking about when we talk about capacity is size for ABIS, not theoretical conditions. So don't over optimize and allow for kind of margins within your design. And then the last one is caution. So there is still so much that we don't know about. So actually making sure that there is a feedback loop involved with the retrofits that have been taking place. Identify, assess, and mitigate the risks, and avoid unevaluated risks. So the 4 C's are kind of key components when it comes to retrofit coordinator training, which if you're looking at a past 2035 accreditation or role, then again, you'll come across these 4 different Cs. So the matrix on the right is similar to the one that I talked about with the Renew project. So this tool is kind of publicly available specifications, so PASS, and this shows the matrix of measures against the measures, and colors identified are the different action consequences. So green is where they don't interact, where those specific measures don't interact with each other. Yellow is where they connect physically but don't have a inherent risk to one another in how they interact. Orange is they interact in other ways, so they probably interact quite a lot. And then red is they're incompatible, so you wouldn't be able to have those certain retrofit measures with other retrofit measures. So if you're currently thinking about carrying out a retrofit project or in the process of carrying out one, using this publicly available matrix would be a really good way to identify some of those initial interaction risks. So this is what the risk management process in PASS 2035 looks like. So everything we've learned over the past 12 years or so has been compiled into what we called a new retrofit standard, which is PASS 2035. So this is the flow chart of that PASS 2035 process. So PASS 2035 does not set physical standards in terms of emissions or heat loss, but it's more a process which, if followed, can help you carry out retrofit successfully. So if we start by looking at the kind of retrofit coordinator roles, so retrofit coordinators as part of the PASS process are required for, if you're carrying out any government funded projects, are required for every project you do and protects the client's interests and public interests. They also help to agree the intended outcome with the client and coordinate the actual project from start to finish. The other part of the PASS 2035 process is having the risk assessments. So when you carry out an risk assessment with under PASS 2035, there are different risk pathways. So you've got pathway A to C. A being the risk pathway is relatively low risk, whereas pathway C ends up being quite complicated and you may require additional kind of retrofit designs. So as kind of it says there, so it determines the qualifications for retrofit assessor and retrofit designer. So if it's a risk pathway C, usually you'll need the retrofit designer as well. The other part to PASS 2035 is that it kind of takes the context of a whole dwelling assessment. So it sets the scene of what the context is, the condition of the property. So whether, the windows are in a poor condition, or how many occupancies and the types of occupancies you have in the property, the current energy performance based on the data or kind of recollected data, what the ventilation of the property is, so through kind of air tightness testing, and the significance of the interactions between the different measures. So usually what happens is you start with the preliminary considerations, or you start with a project inception, and then you figure out what kind of your preliminary considerations or designs are for that, whilst also getting those different engagement advice. Then the retrofit coordinator, assessor, designer, evaluator gets involved before carrying out the dwelling assessment itself. So it's the actual dwelling assessment or the PASS 2035 assessment that will determine what the risk pathway is and what additional medium improvement plans need to take place. So the improvement plan options then take place, and then that's when you can start doing the designs. So during that medium term improvement plans, you'll get advice on what those improvement options include. So by improvement options, we mean what measures would be suitable for that specific property before then designing it. So once the design happens, it's then around the installation. So actually mobilizing and pre-installation building inspections for that specific design, the installation itself, testing the property, commissioning it, and then handing it over to the resident. With the handover, the retrofit coordinator will also support in providing that handover advice package. Similarly, when you carry out the installation and carrying out the testing, that's when the monitoring and evaluation process happens. And again, if there's any other unintended consequences of the retrofit, it will go back to the retrofit coordinator to go through this process. I think I've just talked through this, but yeah, you've got the design process, which shows the improvement option evaluation and the medium-term plans. The design process also talks about what the construction detail is, what the moisture management is for the property, what ventilation upgrades are required, and then any other extra requirements for traditionally constructed and protected buildings. So, for example, buildings that are listed or within areas of outstanding natural beauty. Then you've got the installation. So again, if you're carrying out any installation, it must be compliant with past 2030, 2019. So making sure your installers are past 2030, 2019 accredited. And so that way, when they're carrying out the installations, they're aware of those different kind of thermal bridging and interaction risks. Includes testing, commissioning, and handover as well. So once you're doing the installation, they have to carry out those different testings and making sure that the handover advice packages are carried out. And then lastly is the valuation. So this confirms what the outcomes are going to be and whether they're achieving those intended outcomes, investigating any discrepancies after having carried out those different tests and any kind of unintended consequences. The last thing we're going to be looking at resources then. So I think this is resources in terms of yourself actually. So what we ask, if you still want to find out a little bit more about how to manage risks when it comes to your specific projects, we recommend completing our mandatory kind of self-assessment. So if you are a social housing landlord or a local authority looking to pull together a project for future funding, then please do submit a self-assessment with us if you haven't already. That way we can get in touch with you to talk about your project one-on-one, and the support is completely free, so you don't need to pay for any of it. It is fully funded by the Department of Energy Security Net Zero.